Question number 16 from current electricity, another regular featured question that we generally discuss in the class. And it says something like this. There are two electric bulbs rated 25 watt, 220 volt. So from the rating, what we can do is that we can always calculate the resistance. This is the wattage rating, this is the specified voltage, and one can always calculate the resistance by Vs square by W. So the first thing you did is that from their respective wattage rating and specified voltage, we have calculated the resistance. The resistance is known, and now that system is connected across 220 volt, I think now it has become a very, very fundamental question that two resistors are connected in series across 220 volt, and you need to calculate the power drawn by R1 and R2. Well, you can do that by so many different ways, out of which one is calculate the current and find the power dissipated, I square R. So that's a very simple thing. All it requires is a simple step of calculation. You do that, pre-calculated it. Option number 4 is going to be the correct one for question number 16. Time to move to question number 17 now. The 17th question that has been drawn from principle of communication. Now remember, 5 or 6 questions back I had said there are areas where JEE main particularly focuses, and those areas are the area which is excluded in JEE advanced syllabus. Like POC, the principle of communication, does not exist in JEE advanced syllabus, and generally it has a very high probability to be asked in JEE mains. So keep this rule of thumb with you. You would be in a great advantage. It's a very straightforward question that has been generated from AM. A 100 volt carrier wave is made to vary between this. So if this is the, VCM or VC naught, the amplitude of the carrier one, and say is made to vary between 160 and 40. So quite obviously, this is VCO plus VMO, and this is VCO minus VMO. That's very straightforward thing. Now, VCO, the peak value of the carrier voltage, that's 100 volt, which is given. Either from this or this, you can calculate the peak value of the modulating signal would be, of course, 60. So I need to calculate the modulation index, which is the ratio of this divided by this. So quite obviously, the value is going to be 0.6. So option number 3 would be the correct option for question number 17. Let's move to question number 18. Question number 18, the question derived from simple harmonic motion, and the question wants us to calculate the frequency of small oscillation. The arrangement is somewhere here. It's a top view. This is a horizontal rod and two identical springs are kept, and this has been slightly displaced, and the oscillation happens in the XY plane, and we need to calculate the frequency of the resulting oscillation. Not a very tough deal, a bit, maybe 2 to 3 steps is essential. Now here, when I oscillate this thing by a very small angle here, let me call this as theta. So this spring, both will be compressed. As a result, they would be giving the restoring force, and that restoring force will provide the restoring torque. And we can put the assumption of small oscillation right beforehand, considering that we are not a novice. Fine. So in that case, if I want to calculate the torque would be the restoring force is KL by 2 multiplied by theta, because this is L by 2 theta, multiplied by L by 2 would be the distance, multiplied by 2 would be the factor that's essential because both the springs are producing torque in the same direction. That's fine. And now after that, what we would be saying is that this given torque would be KL square by 2 multiplied by theta. And the time period now is t equals to 2 pi under root moment of inertia I by KL square by 2. And how much is the moment of inertia going to be? Yes, of course, for the given oscillation, the moment of inertia is going to be mL square by 12. You put the value and calculate the inverse of the time period. That would be the frequency. Your ultimate answer is going to be option number 4, which is the correct option for question number 18. Now let's go to question number 19.